it turns out that's Humpty Dumpty. And Humpty Dumpty fell off a wall, and his eggshells fragmented into little pieces all over the place. And so what happened is that's the shape of the universe. And I pieced Humpty Dumpty back together. And there's only one number per tile. Those are called whatever you want. Penrose columns, they named them after him, Penrose tiles, when they put tiles on the sun to model the sunspots. I use these tiles to model this, where the big red boundary lines come around it. Now you see how it's good I'm explaining this to you, because you may not have noticed those thick red lines. So you might see that I'm very slow with you, but it's deliberate, because it's my duty to make sure you don't miss anything. Everyone still with me? So these are called world boundary conditions lines, these big thick red stuff, okay? And these numbers, it's one number per tile. And this is a chessboard, but it's a 3D chessboard. And this shape here is called, yes, we know it's a donut, but in science they don't call it that. Torus, T-O-R-U-S, or tori means multiple toruses. Our body was named after it. What's our body called? A toroid, human torso, T-O-R-S-O. You know what that means? It means you're getting put through the grinder. It means, because that hole is a tor. It means it's a hole. And it means that everything is either imploding into that hole or exploding out the other side. And if you don't have that hole, you're toast. It's all over, because it's always in and out. Compression, decompression. Implosion, explosion. And it's doing something else. It's thermal. And that is this talk today. It's about heat dissipation, which is the very foundation of all physics and astrophysics, because this is modeling a black hole. And nothing goes through the hole in the center, or the hole wouldn't exist. It processes, see this red line? Spirals and defines the hole by being an aperture like our eye. Because there's something, I believe, emanating in this hole that's causing this hole to not close. Okay? And that's what I'm harnessing, and that's what I found. And that emanation that's shooting out of here is traveling in a straight line. You know I could talk on this picture for an hour, and you don't have that time. And I have so much more to say, but I'm going to cut my own throat and move on. So Abha Taurus, 18 by 36 top-down view. So it's 36 on the circumference, 18 right here. Next, please. Now, I might just come back to this stuff later on. So I think I'm going to now whip through the conference. I'm going to give you I'm going to give you a preview instead of plodding in the mud and being slow. So this is a 60-degree angle view. No number, oh, we'll do it right here. I didn't say next. 8, 9, 1, 2, 3, 4, 5. I might add that any image of this whole presentation is, in a hologram, the whole is in the part's in the whole. Doesn't matter which you take image in this explanation. I'm laughing because I'm thinking how extraordinary it is what you're seeing there. There's no words to describe the miracle of putting those numbers into place and seeing the donut from different perspectives. You have no idea how big of a deal this is in all of our lives and mankind's. So no number can ever be used amount of times more than any other amount of times. So 7, 8, 9, 1. So if I have one 50 times here, there's got to be two 50 times. It isn't if you use any number more times than any other times, you've forced an outcome. You're breaking the rules. And you've always used numbers for data. And you always move numbers around. You kept the function stationary. In a store, you'll add and give a total, or you'll multiply. I discovered that numbers don't move. To quote one of my best students, he says, numbers are stationary vector interstices. They're coming from emanations. I'm not going to show you those emanations right now. Or